This is the fifth and final video of our series on learning how to name chemicals and how to write their formulas. In this video, we are going to concentrate on naming some very simple molecular compounds. Molecular means they are bonded together covalently. So we have two or more atoms that are sharing electrons with one or more covalent bonds. So if you have a covalent substance, you should follow these molecular rules, not the ionic rules that we've been learning in the previous videos. So by watching this video and doing the exercises, I hope that you'll be able to look at names that have prefixes and recognize them as molecular compounds and then write their formulas from their names. Or the reverse of that, if given a formula, be able to write their name using prefixes. That's the main rule that we're going to add for how to do covalent compounds. Now again, we're going to stick with very simple things. So we'll concentrate mostly on binary molecular compounds, things that only have two elements. Usually, when the two elements that are bonded together are nonmetal, they will be covalent, and consequently they'll follow the rules that we are about to use. There are a few cases where metals and nonmetals bond together in a more or less covalent manner, but for the purposes of this course, we typically say if it's a metal bonded with a nonmetal, we're going to treat that as if it's ionic. Unless you know the electronegativity rules and you can check for the ionic character, let's just follow this general rule of thumb. If we have a metal, like in this case manganese, and a nonmetal, like oxygen, let's follow the ionic rule. So we would call this manganese 4 oxide. It's called 4 in Roman numerals, not because there are 4 of them, but because that manganese has a +4 charge. Roman numerals give the charge. In real life, this is often named, though, with a covalent name. So the covalent name for this substance is manganese dioxide. There are also other exceptions to the rules of how to name covalent things, especially things that have common names that everybody uses. For example, H2O, everybody calls that water. They don't call it dihydrogen monoxide, or even oxidane is another name for water. NH3 is called ammonia. Nobody calls it nitrogen trihydride. O3 is called ozone. N2 and other diatomic elements are just called by their element name. So, in case you haven't heard, there are 7 elements in nature that bond to something. If nothing else is around, they bond to themselves. So if you were to get a sample of hydrogen gas, for example, you would not have hydrogen atoms by themselves. The hydrogens would be bonded in pairs. Nitrogen and oxygen that you're breathing in right now, that's 2 ends bonded together covalently with 3 bonds actually. Oxygen has a double bond. So 2 oxygen atoms are joined together when you breathe them in. You don't breathe in single oxygen atoms. So it really would help if you would learn these diatomic elements. One way to do that is to look at the periodic table. Now you just have to remember H2, that's always going to be diatomic. In other words, it's when you're writing hydrogen by itself, you always write H2. If it's bonded to something else, that's fine. You might have 1, you might have 2, you might have 3. But if it's not bonded to anything else, you write H2. The other diatomic elements can be found by this little rule of thumb. Start with 7, make a 7. If you look on the periodic table and start with element 7, nitrogen, and imagine a 7 being drawn on the table like this, do you see this 7? Those are your diatomic elements: nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So here are the basic rules for writing simple binary molecular or covalently bonded substances. First, you write the less electronegative atom first. You may not know what that means if you don't know what electronegativity is, But if you just look at this chart, you'll get an idea that if you ignore the noble gases, which generally don't make compounds, and start with fluorine, in the upper right-hand corner there, fluorine, that has the highest ability of any substance, any atom, to pull bonding electrons to itself and hang on to them. Whereas if you look down at cesium and francium on the left corner of the periodic table, they have a very, very low electronegativity. So you just sort of imagine a diagonal line going from fluorine down to francium, and the further away it is from fluorine, that's the element that goes first. What makes the covalent compound naming system a little bit different than the ionic is that instead of giving the charge, they don't have a charge, you have to give the number in the formula, the number of atoms in the formula. So we will give it a Greek prefix, except for the first element. If the first element in the formula has only a single atom, we typically don't call that mono. But if there's two or more atoms, then you will give it a prefix. And the last rule is just like with the binary ionic substances, we're going to change the ending of the second element to IDE. Now those prefixes I was mentioning earlier, there's mono, that means you have one atom, di, that means you have two, and three is tri. Those are the ones you'll run into most often. The others follow the Greek, so 4 is tetra, not quad. 5 is penta, 6 is hexa, 7 is hepta. Then 8 is octa, 9 is nona, and 10 is deca. Hopefully you're familiar with those prefixes from mathematics classes. You do omit a syllable here and there sometimes. I'm sure that we're not going to count that wrong if you accidentally add in an A and call it pentaoxide instead of pentoxide, but generally the A is omitted when it's bonded to oxygen, and there are a few other cases where the A might disappear. So here are some examples. I see CO. There's one carbon and one oxygen. That's carbon monoxide. Do you see how we dropped the mono and made it mon instead? CO2, that's carbon dioxide. Two oxygens bonded to one carbon. PCl3 is phosphorus trichloride. CCl4 is carbon tetrachloride. Now you'll notice in those first four that the first atom is a single atom. We did not refer to any of those as mono. But in the last example here, N2, we do have to give a number, a prefix. We're going to call that dinitrogen. And there's only one oxygen. We always give a prefix to the second element, so we're going to call that monoxide. Dinitrogen, monoxide. Let's just do a few of these. Why don't you pause the video for a second, take a look at the question, and see if you can pick the correct choice. P2O5. The correct answer is C. There are two phosphorus, so we call it diphosphorus. You'll notice we don't change the ending. We don't drop any syllables of the first element. The second element we change to IDE. So instead of oxygen, we call it oxide, and we have to tell how many. There's 5, pentoxide. What about this one? The answer is A. Dichlorine heptoxide. 2 chlorines, 7 oxygens. And what about this one? Did I fool you? That is the diatomic element chlorine. You don't call it dichlorine if it's one of the 7 diatomic elements. You just call it by its element name. So one last little joke here from Chemistry Cat will take us out. That's our unit on how to name some simple formulas and compounds, how to write those formulas. So I hope that you will practice and get better at it, because we are going to be using names and formulas for the whole rest of the course.